Use the data in the following table, which lists drive-through order accuracy at popular fast food chains. Assume that orders are randomly selected from those included in the table. We have drive-through restaurant. You see the columns represent the restaurants A, B, C, and D. And the rows is an order accurate and order not accurate. Now it says if one order is selected, we want to find the probability of getting an order from restaurant A or an order that is accurate. Are the events of selecting an order from restaurant A and selecting an accurate order disjoint events? So we want to first find the probability of getting an order from restaurant A or an order that is accurate. So first thing is first, what we need to do is we need to find the totals. Okay, so we need to find the total of each column, and then we got to find the total of each row. So if we want to find the total for the column A that represents the order accurate and order not accurate, so again we want to find the total here. So if we add 337 plus 36, that's going to give us 373. If we add 274 with 56, that gives us 330. If we add 233 with 32, we get 265. And if we add 130 with 15, we get 145. Now what we want to do is we want to find the total going across. We want to find out what is the total of the entire row for order accurate. So when we add up all these numbers, we get 974. And when we add up all the rows from the order not accurate, that gives us the following, 139. Now we want to find the total of this entire table. So in order to do that, we can either do two things. We can add these two, which is, let's see here, we take 974 and add 139. We get a total of 1,113. Let's add this entire row at the bottom here. So if we take 373 plus 330 plus 265 plus 145, then that equals 1,113. So therefore that's given us the total, the overall total of the drive-through restaurants. Now if we let A represent the order from restaurant A and let B equal the order that is accurate, we want to find the following, because we want to find out what is the probability of getting an order from restaurant A or an order that is accurate. And that's going to equal the probability of the order from restaurant A plus the probability of the order that is accurate minus the probability of the order from restaurant A and the order that is accurate, because we want to make sure that we don't count something twice. So first thing we want to do is we want to look at the following. All right, we want to find out, okay, what is the probability of A? Well, the probability of A, okay, is the order from restaurant A. So the order from restaurant A has a total of 373. And then we want to divide it by the entire total, which is 1,013. Plus, now we want to find out what it plus the probability of B. Well, the probability of B is the order that it is accurate. Well, the order that is accurate has a total of 974. So that's going to be 974 divided by the total amount of 1,113. Okay, now what we need to do is we need to subtract where they intersect, meaning where does the order accurate and the restaurant A intersect. So what that means here is if you look here and then here, you can see that this amount here represents where they intersect, which means it's being counted twice. So we need to subtract that amount over 1,113. So now what we do is we just need to then go ahead and add and subtract our numbers. So we get 373 plus 974 minus 337, which gives us 1,010 divided by 1,113. And that gives us a decimal of 0.907457323. And in the question, they want us to round it to 3 decimal places, so we're going to round it to 3 decimal places to get 0.907. Therefore, the probability of getting an order from restaurant A or an order that is accurate is 0.907. Let's go ahead and put that answer in here. So 0.907, and there is our result. Okay, now the next part of the question is, okay, here it's saying, are the events of selecting an order from restaurant A and selecting an accurate order disjoint events? So here we're looking at the word and. Okay, now for two events, restaurant A and accurate order to be disjoint only if the probability of A and B is equal to 0. Well, however, if we look at the probability of A and B, well, that was 337, and divided by 1013 gives us a probability of 0.302. Well, we can see that that doesn't equal 0. Therefore, we would say that the events selecting an order from restaurant A and selecting an accurate order are not disjoint events. So we would say that the events are not disjoint because it is possible to receive an accurate order from restaurant A.